So I've been doing consulting for a couple of RAG companies, and the playbook usually is the same thing. The first thing you do is you join the team and you realize the engineers aren't really being quantitative with how they're describing problems. They're using words like, it looks like, it feels like, it looks a lot better, without actually saying this metric improved by that much. And so the first problem we address is just understanding metrics, right? Like people want to think about like the LLM as a judge metrics, but there are actually just precision recall metrics people need to understand and really internalize. And there are techniques to improve that and design and synthetically generate data sets to help you evaluate that ahead of going into production. Once it goes into production, the biggest issue is people lack the ability to do good observability. You maybe have questions being asked, you maybe have thumbs up, thumbs down, maybe the copy for those buttons are not as good as they should be. Maybe we're not using full text search in conjunction with embedding search. Maybe we are not using cohere rankers even though we can afford the additional latency budget. And then we can also answer questions about what goes into context and whatnot. But ahead of all of that, to go back to the first point, we really need to nail down precision and recall and understanding and internalizing why that matters. Once the observability is in place, now you can do things like figure out, okay, when I ask a question, it is returning like 10, 20 documents. What was the cosine similarity of the text chunks? What was the cohere re-ranker scores for those text chunks? What are the averages? Do those average values predict whether or not it's a thumbs up and thumbs down? If it doesn't, is the thumbs up, thumbs down metric the one I really care about, right? You know, the difference between how did we do versus did we answer your question could be huge, right? Because maybe in the first one, how did we do? We did answer the question, but it was a bit slow. It was a bit verbose. Is that really what we're trying to capture with the thumbs up, thumbs down button? Unsure. There's also like a tons of novelty effects, and those tend to wear off, and you really should be reading results maybe like weeks after launch. One of the biggest things you can do is just looking at the questions ordered by the cosine similarity and the re-ranker score and just finding questions you're doing poorly on. Not doing poorly in the sense that we know we didn't answer the question, but if the retrievers themselves don't feel good about the system, we should have learned something about that. When I go back to number one around synthetically generating data for evaluation, what Ivan and I found was if we did like Paul Graham essays and we took Paul Graham essays, took the chunks and said, okay, AI, give me a question that this chunk would answer. And then we would test whether or not that chunk was returned in the document. It was like 96%. It was like really good. But when we did the same task on GitHub issues, the same prompt, same task, same evaluator, got like 65%. Different data sets have different difficulties. And if we can't even nail synthetic questions, we understand that the question is going to be really challenging. Okay, so now you have a list of questions with their performances. So what do you do with that? Now that you have this list of questions, you can do things like topic modeling. You can go figure out, are there certain domains that our users are asking, and does it make sense to even model it that way? I usually find that it's helpful to model it in two specific ways. One, the topics. These are the way the words are, right? These are like the embeddings that we might be searching. This is the content of the data. And then there's capabilities, which is more like, oh, actually, if you do the questions are just asking for the document. They're not trying to actually get an answer about a document. They just, where's the file for X? Some things might be time related. Show me the latest X. Show me the most recent Y. Maybe that's subjective. Maybe it's around the metadata, right? Maybe it is, show me the last document modified by JSON. That has nothing to do with embedding. You need to have some kind of modified date filter. You need to be able to do some kind of like keyword matching on the created by name. Those are capabilities, and those are things that like your RAG system can't do unless you go code that into the problem. But ultimately, being able to cluster these, find those groups, find those topics, find those capabilities, you can then do group bys against those attributes and figure out what the counts, the frequencies are of these questions, and also what is the average score of these systems. By doing that, we can figure out what to prioritize. Okay, maybe it's the case that document search is 60% of the question volume. This is sick. We don't need to do RAG then. We can just do search. And the thumbs up score is like 90%. And the cosine distances are like close to 0. So great, this is pretty solved. What's probably going to happen is latest documents created by JSON probably has terrible results, right? And not only do they have terrible results, that's a problem your language model can't solve with embeddings. And maybe that's only 2% of the question. So it's important. We have to implement this, but it's too low stakes to really solve this. Maybe instead of trying to like kill yourself over solving this 2% of the distribution, maybe you just say, okay, put in the prompt. We cannot ask questions about who made documents. Just by saying no, you've improved your overall success by 2%. Because if you just said no to the questions you can't handle, maybe it's something worth building in the future, but for 2%, there's probably something else. Maybe something else around date ranges is more important. Maybe that's 20% of the questions, and we can't do any of that. And so now, not only do you have a system that can do observability, you can use that observability, figure out the questions, the scores, and the performance to find groups and segments. And by segmenting those groups, you can then find the count and the quality, and then prioritize based on the volume of what your production traffic looks like, rather than just making stuff up or hoping that you could build a system that's 100% accurate when that will never be the case. Once you have all of that in place, now you have a handful of different search tools. Maybe you have the ability to search documents. Maybe you have the ability to do RAG using date ranges and modify timestamps and whatnot. Now you have many search systems, and I honestly recommend just having very specific tools currently, and just recognizing that as these tools improve, and once these tools are well documented and well understood independently, then you can wire things up as an agent and just have a better system that has less UI complexity. But even that, if you think about something like Google, day one they have websites. Day two, they'd realize that the only way to find a restaurant is if it showed up in a review. And so maybe they build out maps, right? Maybe the only way to find a photo was if it was in a website, and they go, oh, maybe we should have photos. And then, okay, video is a great data set. Let's go buy a video asset, and they buy YouTube. And it all comes down to specializing in these specific verticals: websites, maps, videos, photos, shopping, books, whatever it is. They are prioritizing and making investments in each of these segments rather than trying to do everything all at once by just claiming that embeddings can solve all of that. And I think that's the big issue that many companies are running into now, where they just believe that. But honestly, I was fine-tuning multimodal embedding models in 2016. And I did that because I didn't understand how to deploy OpenSearch or Elasticsearch. Using embeddings and using vectors to do search is approximately an intern project. And real systems need to be much more complex, and you have to prioritize and figure out how to spend the time and the money to make these systems better. And embeddings are not all that you need.